Was it on Teams or
Email,
email?
like your BSC email.
What email did you use? I can put my email.
The one you gave in the chat, the S-ANUSHAA@bst405.org.
Oh, that's weird. Okay. Um. Uh. I'll figure something out after this meeting on how you can send me the homework.
Okay, thank you.
Yeah. I'll let you know after this meeting. Okay. Let's get started real quick. Is this okay? That's recording. Okay, so this is our first lesson. We only have time for one more lesson, unfortunately, before invitationals. So we'll do that next week. It's not going to be at the same time just because I think Reach for the Stars also happens at the same time. And I think a few of you guys are also doing Reach for the Stars. So it's probably going to be either an hour earlier or an hour later. I'll let you guys know in the Teams channel, but yeah, let's get started. So just a quick agenda. We'll go through the rules. We'll do a quick homework review. I think I got like 4 or 5 responses on homework, but if you haven't had the time to complete the homework, or yeah, if you haven't had the time, this is a great chance because I'll go through like basically half of our homework a little bit more in depth. And then we'll also watch a video. Um, there's this dude, he explains topographic maps like really well. He's where I got like my entire foundation of Road Scholar off of. And so go watch his video and I'll elaborate further on, what he talks about. And he also has like great practice problems in his video as well. And just so you know, you guys will get this recording and the PowerPoint after the meeting. I'll share it on Teams. Yeah. Let's see. So, just because not a lot of people are here, I'm not gonna ask you guys how you split it up, but I'll just say this: you guys should split up your rules manual, and this is because if you guys look, there's what like 4 different sections, right? There's topographic maps, highway maps, student created, and satellite and photo slash internet maps. And realize that you only have 50 minutes during your event or during your test to get through like over 50 or 60 questions. And these questions are usually grouped by the type of map it is, right? So you'll have like 20 questions on topographic maps, you'll have maybe like 10 on highway, you'll have maybe 2 or 3 student created maps because you actually have to like create a map, and maybe the last like 10 or so will be on satellite photos. And because of that, one like it's not that efficient if one person or if both people know everything about every single map. Rather, um I think I mentioned this in the team channel, but the way we split it up, me and my partner, was that one sec. So basically, um the topographic map was I did topographic map and student created maps, and that was because the student created map is there's usually only 1 or 2 questions on it, and there's like 20 or 30 on topographic maps, so it evened out. And then I'll do this in a different color real quick. My partner did highway and satellite photo maps, because there was usually like 10, 15 questions each. And that way, when we got our test, we just ripped it apart, right? We took like whatever 10 pages they were. I took like the first 2 pages that were completely topographic. He took like the last 2 or whatever pages there were on highway and satellite. And that way, in 50 minutes, we split it in half. Like we basically split the test in half. And that way, we were able to answer like almost all of the questions that there were. And that made us a lot more efficient, compared to like people that people that like studied all of them. Yeah. Let's see. Sanchi, do
Um,
you have a question? Yeah.
so the way me and my partner split it,
Mhm.
I'm doing topography maps and well, like in the section that said map drawing, is that student created map?
Yeah. So basically, there's like usually one or two questions that they'll give you like a bunch of instructions. They'll be like, hey, in the northeast coordinate or quadrant, there's like a marsh, right? And draw in the marsh. And maybe they'll say
Yeah,
there's a highway running across
I
parallel to like something. Yeah.
yeah, I know. So the way me and my partner just split it like before this meeting where I would do topography and map drawing.
Hmm.
Is map drawing student created maps?
Yeah, basically, yeah.
Okay, so and then he would do highway maps and satellite images.
Yeah, that's basically how me and my partner split. Wait, who's your partner, real quick?
He's not here. I think he had like a baseball game.
Oh,
His
okay.
name is Sanjay Urali.
Okay, cool. I'll note that down. Okay, yeah. So that's just how we split it up. Let's see, next slide. Sorry, one sec. Well, that's really weird. Hold on. Okay. So a reminder about invitationals. Um, you guys have invitationals in 2 weeks, I think. Yeah, in or maybe yeah, 2 weeks. Um, so just make sure that like a few days before invitationals, I think like because invitations are coming up so fast, maybe like a day or two before. If you're doing any silo studying, just dedicate it completely to doing practice tests, right? Like, don't take any more new notes during then. You should be doing completely random practice or random invitational tests that you find online. I have like a folder full of invitational tests that I did. I could provide that. Yeah, but just dedicate those few days to just doing practice tests. Okay, so notes review. Yeah, I'll let's see where's yeah. So basically, your guys' homework was to take notes on this entire thing. Uh, I'll go over. Let's see. I'll go over topographic maps and maybe what else is there? Highway maps, I guess. And then in the next meeting, we'll do map drawing and satellite images. But this is a great time if you haven't done the notes, do them right now. Or if you already have notes on this, you can add on to it. I'll go a little bit into depth, maybe some stuff that isn't like necessarily on the wiki. So yeah, this is just it's a great introduction. Um, we'll skip over that. So like I said, um, you have 50 minutes to do the test. It's going to be topographic, highway, map drawing, and satellite. Um, Memorizing primary and secondary directions is important. So, uh, you don't want to like be struggling in the middle of your test trying to figure out what's north and what's south. I think that's kind of basic. Um, so just having a great like sense of direction, like knowing, okay, between north and east is going to be northeast, or between south and west is going to be southwest. And you should ideally know where north, south, east, and west is. On your test, they'll say which direction is north, and you should be able to figure out like the moment they tell you, oh, north is up, you should be able to figure out, okay, that way's east, that way's west, and that way's south, right? Um, you also, I don't agree with the map folding part. I don't think once I've ever been penalized for incorrectly folding up a map. They usually just don't want you to like leave your space messy. So just don't like yeah, just clean up after yourself basically. So starting on to topographic maps. Um let's see let's go through the parts really quick. So they talk about the map location. It's going to be top right corner of the your map. Your map's called a quadrangle. There's I think 9 quadrangles. Um, if you look at part C, it talks about the surrounding quadrangles in the area. So yeah, in your quadrangle, you'll find the map location in the top right corner. I'll say the location. I'll say the state. A lot of times the most basic question is, hey, where's your map located, right? And so you just go to that top right corner, you read off whatever location it says and write it down. B, it talks about neat lines. So this is just basically your boundaries, right? Um, they say it keeps the map neat. Yeah, just your outer boundaries. C, like I talked about already, surrounding quads. So these are the 8 bordering quads. I don't know if you can see really well. If you zoom into the photo, it shows you your map is usually the center one, and then it'll show you top, bottom, left, right, and then all the diagonals. And then over here, it'll say, okay, it'll usually have them numbered as well. So it'll be like quadrangle 1 is this location, quadrangle 2 is this location. So some of the questions you could get is what quadrangle is located like southeast, right? So you just look in this area and you'll figure out which quadrangle is located southeast. For D talks about graticule tick marks. Okay, so these, like this drawing represents really easily. These are going to divide the map into 9 sectors, right? So if you just imagine this map divided into 9 sectors, you could see a line going down here, maybe a line down here, and then 1 and 2, right? And these tick marks are going to describe exactly where this map is divided. Don't worry too much if you cannot find the tick marks because they're usually so small and minuscule that unless you just happen to be looking at something that's in that area, you don't really like see them. And so my advice to that is just going to be imagine it cut into 9, right? Imagine your map is cut into 9. When they talk about sectors, right? So those are, yeah, real quick, the tick marks divide your quadrangle into 9 different sectors. So if they talk about sector 7, just in your mind, cut it into 9 sections, and quadrangle 7 is going to be here. If you can find the tick marks, that's amazing. But a lot of the time you can't. And like I advise, don't waste your time looking for a tick mark. Just imagine it, right? Um, E, we have latitude and longitude. So that's really difficult. I think that was probably one of the hardest things. A lot of those questions I ended up skipping because it was really just a hard concept to understand. I'll go over the basics today, and then next week we'll go a little bit more into depth because it's a really difficult concept. Um, like being able to calculate the seconds and minutes and whatever. So, in these corners, you'll see your latitude and longitude. You'll see one in each corner, top right, top left, and then on the bottom corners as well. Um, and basically, real quick, there's a degree, right? And there's 360 degrees in a circle. Um, then here, if I can annotate this thing, can I? Okay, so you have a circle. There's gonna be 360 degrees, right? And there's gonna be 360 degrees. So in each single degree, you're gonna have a minute. And a minute, there's going to be 60 minutes per degree. And that, I think they just go based off of the hour. Like in an hour, there's 60 minutes. So in a degree, there's going to be 60 minutes, right? And like you can see here, minutes are identified by the apostrophe. So you're going to have this tiny little comma following your minute. Then they can also be broken down into seconds, right? Like you take in a minute, there's 60 seconds. If you go back to map drawing, again, there's 60 seconds per minute. And these have 2 commas or 2 apostrophes on the top, okay? So the more specific you are, the more points you get. If you can calculate to the second, that's amazing. If you can calculate to the minute, that's also great. I don't recommend just calculating to the degree. That doesn't get you all the points that you want. So as you guys should know, latitude measures north or south, and you always want to add your north or south after the coordinate, right? And otherwise, like it says, you will be penalized. So you want to be as specific as possible, add as much detail as you can. let's see. To calculate the latitude of a location, take the distance from the lower sector boundary. So if I get rid of the annotations real quick. If you take the lower sector of the boundary, right? So lower sector boundary. So if I go back to taking sector 7, right? The lower sector boundary is going to be right along there. It's going to be the boundary of the map. And then let's see. To the target object, and you want to calculate this in millimeters. So you're just going to take your ruler. Let's say our target object is this tick mark, right? So you're just going to measure the distance from this line all the way to the tick mark in millimeters. If you have centimeters, you can do centimeters as well. Just multiply it afterwards. Multiply it afterwards. And divide it by the east-west distance across the sector, and then multiply that answer by, divide it by the north-south distance across the sector and multiply this by 150, right? And this is the distance to the target object in seconds. And then you add the number of seconds you have from the value of the degree line, right? So if you take this value, you're just going to take whatever measurement you got, multiply it by 50, that's your seconds. And then you're going to convert it to minutes and degrees, and then you just add it to whatever value you have in that corner. And that's ideally just going to be your latitude of that location. And then you basically do the exact same for longitude. Once again, make sure you label east or west after the coordinate. And instead of taking north-south distance, you take east-west distance, and then multiply that answer by 150. And I'll do a few examples if I can at the end of our time, but otherwise I'll go over them next week. So, series. What are we on? F, right? So F is, where's F? Right here. So your Siri is usually going to be located under the map location. Like it says here, most of the maps you encounter use the 7.5 minute series. I've personally never seen anything other than the 7.5 minute series. So yeah. Next they talk about scale. So that's going to be right dead center at the bottom of your map. And most of them do end up having a scale of 1 to 24,000. So like it says, both scale and series are common questions, so make sure you know the answer. And it also says some tests might have a different series and a different scale used. At invitationals, you most likely won't get a different type of test. You'll usually get 7.5 and 21 to 24,000. So you guys don't need to worry about that for invitationals. Legend. I think we all know what a legend is. Legend basically is just gonna say, hey, if there's a box, or like a shaded in box, that means it's a major city. If it's a hollow circle, that just means it's a smaller city. Or yeah. So yeah, and it also might explain what types of roads are featured. So maybe a dotted line is the highway, and maybe a straight filled in line is a normal road, something like that. Contour interval. So that's probably one of the major things about topographic maps. My video later on will explain really well what contour intervals are, but they're basically, if you see, I don't know if you can see that well in these images, but they're kind of like gray or brown lines that stretch across the entire map. I think you can see them over here. I'll see if I can like outline them, but there's like a line that goes like that. There's, let's see, there's a ton in this section that are going like that. But yeah, those are contour intervals. We'll go over how to calculate that later today. And then there are also index contour lines. These are darker contour lines. They'll be important, but we'll talk about it later. Magnetic declination. There's a lot of questions I encounter on these, but it's really a simple topic. So if I go right here, there's going to be ideally 3 lines drawn here. Your middle line is going to be the the middle line is going to be true north, right? That's where like the actual north is. And then one of the other lines is going to say magnetic north. And the difference between true north and magnetic north is kind of like if you go, like if you pretend that this is the North Pole, right? And that the flag is your true north. A compass, if you take it right next to this true north, a compass isn't going to point directly at true north. It's going to point like maybe 1 degree to the side or maybe 1 degree that way. It's not going to point directly at true north, and that's considered your magnetic north. And in day to day life, the difference is so tiny that no one really cares enough about it. But in map reading, it's somewhat important. So, yeah, that's just the difference. And in that corner in J, you'll see the difference, like how many degrees different it is. And then the other line, the third line, is going to be geographic north. Geographic north is kind of like the north that the map takes. So you're going to have your true north, you're going to have your magnetic north, and then maybe you'll have your like wait, hold on. You'll have your geographic north is going to be like right down the middle or something. And geographic north is basically the north that the map is taking. I wouldn't waste too much time like understanding what each north is. Rather, just be able to find it in that corner when that question comes. PLSS. Okay, this is another complicated topic. Uh, I'll go over it more next week and maybe a little bit more this today if we have time. But um, let's see. I have additional resources I'll post on Teams, but basically, um, like it says, you want to identify the township and range of an object. So let's say they ask me, give me the PLSS coordinates of sector 7, right? And what you're going to do is you're going to start with the township. And if you look at these outer boundaries over here and over here, on these sides, you'll often find something saying hold on, T dot S dot 5 or T dot S dot 8. And that's your township. It's telling you like you're in township number 5, basically. And then you're also going to have something called the range. And it's going to be R dot 5 or maybe like R dot 9 or something like that, right? Yeah, and yeah. Also remember, they're often going to tell you your south or east. So I wouldn't worry too much about the difference between Township 5 South or Township 5 North. That isn't going to show up on the test. But just make sure you write T.5S and R.5E, right? And that's your township and range. Okay? And then after you get your township and range, there are going to be 36 sections. That might sound daunting, but yeah, there's 36 sections. So the number of this section can be found on the quad in the center of the section, right? So what's going to happen is this thing, wait, hold on. Okay, so basically your township is going to be like this entire thing, right? Let's say that's your township and range or whatever, right? Maybe this is going to be T dot 5. I'll just do T dot 5S, right? And I'm going. It's also going to be. I'll just keep it the same. R dot 5E dot 5E. Okay, so this is your T dot 5 south and then R dot 5 east, right? And then inside of this, like they said, it's going to be split up 36 times. So I'm not going to draw all 36, but you can imagine 36 different sections. And then your map, which is this quadrangle, is going to take a snippet of this section. So rarely you're going to have it like overlapping two sections, or no, overlapping three or more sections. 50% of the time it's going to be two sections, and the other 50 is just going to be one section. If you imagine there's like lines running that way, right? Your map might occur right here. So you'll be in section 1 as well as 2, 3, 4, 5, 6, section 7. So your map is going to be section 1 and section 7. And this is going to be labeled on your map. So pretend like you might see a 1 over here and a 7 over here or something like that, right? And so that's going to be your sections. And then each section is going to be split into corners. So northeast, northwest, southeast, southwest. And then further on, it's going to be split into another four corners. Again, northeast, northwest, southeast, southwest. And you're just going to locate that quarter for quarter, that 16th. So if I go back to my drawing over here. So inside of this section, you're going to see like it's split into four more times. And then that each individual thing is going to be split into four more. And what you're going to write this as, so let's say we're taking an object that is in kind of a different color. Yeah. In this area right here. So the text of this is going to be, so it's going to be T5S R5S. And then we're in section 1. So let me just check the format for this. Yeah, okay. So it's going to be T5S R5S. And then section 1, we're in section 1. And then we're in the north corner, right? North. Right. And then you're just going to say 1/4. Okay. So this is basically somewhat what like your PLSS thing should look like. Sometimes they ask you to write it backwards. I don't think the grader is going to be that harsh on you, but sometimes you have to write it like the opposite way. 1, and then you write your township and range and whatever it is. But yeah, sometimes they'll ask you to write it opposite. It doesn't really matter that much, but yeah, just keep that in mind. Okay. Moving on. So we did this. We'll do some practice on this. Let me just check what time we're at. Okay. So additional information. I think we have time for this. So let's see, map colors. So I'm gonna send a chart later on. It's like the USGS thing. USGS topographic symbols. Yeah, this one. Is this it? Okay. So when I went to States, this is the only document I took with me, just because I had memorized basically everything else. But this is probably the most handy thing you're going to have. It has all the different symbols that could show up on your test. So, you know, there's this page talks about boundaries, buildings, contours. If you keep scrolling down, it'll talk about glaciers, it'll talk about rivers, railroads, and then more rivers, marshes, roads, surface features, vegetation, right? And so this is probably one of the most handy things you can have. I recommend every single person that takes Road Scholar needs to have this, because of how many questions show up about this. If they say, hey, um, what does uh, you know, what's a symbol that I know? Yeah. What does this symbol mean, right? Right? Well, that's kind of obvious one, never mind. That obviously looks like a church or something. But anyway, let's say they ask what symbol that means. So you're just gonna go down to your buildings area right over here. Oh, and here it is, right? School and house of worship. And let me scroll in real quick so that you guys can see. But that's that symbol that I just drew. The cross and then the black box underneath. So those are really free points if you have this like symbol thing with you. There's another one I have. I'll share that as well. That's also pretty handy. But yeah, that's your map colors. Yeah, I have one on map colors. So like green usually denotes like farmland, vegetation. Purple or red denotes like, hey, this is a highly populated area. There's like tons of buildings and stuff here. Oh yeah, purple indicates revisions. You'll see blue obviously is water and stuff like that. And then we talked about map symbols. Survey controls. So I'm gonna talk about this stuff next week, but yeah, because benchmarks and stuff are like an entire different topic. But yeah, we'll get back to that. Same with azimuth and bearings. It's just another degree system. They're kind of confusing, but we'll go back to that. Let's see, measuring distances. So the easiest way is to take like a scrap piece of paper. I always recommend you have some sort of scrap piece of paper on hand, and you just line it up with your 2 points. So let's say one of my points is here, one of my points is here, right? And I'm just going to take this piece of paper, I'm going to line it up, I'm going to mark the 2 points, and then I'm going to take a ruler and measure the piece of paper, right? And that just makes it a lot easier because you always, like, you're not drawing on your map. That results in a fine. Don't ever draw on your map. But B, if further on, we'll go into like topographic map profiles. Um, if you ever need to profile a map, it makes it a lot easier to profile a map, right? Stream gradient, slope gradient. Okay, I think that's easy. So to find stream gradient, you just find the length of the stream and then figure out the change in elevation. And we'll go over how to calculate like the change in elevation and stuff. And yeah, just times it by 1,000 because you're probably gonna get like some change elevation over so yeah, you're gonna take your change elevation, divide it by your distance, and then times it by 1,000 because you're gonna get like some long ending decimal. So you want to times it by 1,000. Slope gradient is similar to stream gradient. It's gonna be change in elevation over distance times 100. Yeah. Stream flow direction. This will go over in our video. And inset map, it's not going to show up a lot on topographic maps, I don't think. Yeah. So that's basically, I think that's all we have time for on the wiki. But yeah, I'll come back to the wiki next meeting and we'll go over the rest of the stuff. So yeah, notes. Most of the notes I've seen so far are pretty good. Um, I did recommend having a Word document for your notes and make sure that if you have like pages upon pages of notes, you do have a table of contents. But keeping that in mind, like I said, I only went with one page of notes, which were the symbol sheet that I showed you guys to states. And I think it's just because I had 3 years of experience in Road Scholar and I've done the event so many times that I didn't really need notes anymore. I just had most of the stuff memorized. So, yeah, I recommend memorizing as much as you can, but once again, notes aren't going to harm you or anything. So, yeah. Don't be like me. Don't go into invitationals without any notes. It's probably your guys' first time doing the event, so definitely have notes. But maybe next year, if you guys continue to do Road Scholar, you can try like reducing the amount of notes you have and relying more on memory. Yeah. So yeah, this is a short video I have. It explains topographic maps really well. Um, let's see. I think we have just enough time for it. Okay. Let me.
Topographic maps, and I'm going to teach you how to read them.
Wait, can you guys hear that?
Hi, everybody. Today we're going to take a look at topographic maps, and I'm going to teach you.
Can you guys like hear the video?
Yes.
Okay, cool.
Yeah.
How to read them, and we're going to go through some of the rules that will help them make sense. So right now you're looking at a topographic map, and it probably looks like a bunch of squiggles and lines and colors. It probably does not make too much sense to you. Here's another topographic map. Same thing. Probably just looks like a bunch of brown squiggles with some other colors thrown in there. By the end of the video, hopefully you're going to be able to look at a map like this and you're going to be able to see the topography or the shape of the land. So a topographic map looks like this one on the bottom. And basically what they do is they are a map that is able to show us the elevation, the height above sea level, and the shape of the land by using these lines, which are a kind of isoline called contour lines. So on the top, we have a landscape. You can see there's a cliff over here, there's a hill over here. When you know how to read a topographic map, you can actually look at this and you can tell that there's a cliff over here and there's a hill over here. Topographic maps have certain features that you will always see. So let's go through 4 of those features. The first thing you're going to have to figure out is what the contour interval is. When you look at a topographic map, you'll notice that not every line is labeled. For example, this map, we have 300 labeled and we have 400 labeled. Those lines are a little bit darker than the surrounding lines. Those numbered lines are called index contour lines. The reason they only label some of them is because we don't want the map to be too confusing. We don't want to have numbers everywhere. So the first thing you have to do is figure out what the contour interval is. In other words, what is the difference between each pair of lines? Now, sometimes they'll tell you the interval in a key under the map, but more often than not, you're going to have to determine it yourself. So if we start with this map over here, again, we have 300, and it's either meters or feet or kilometers. We're not sure with this map because it doesn't tell us. But we have 300 here, we have 400 here. So our task is to figure out what the contour interval is. What are we going to count by to get from 300 to 400? Now, hopefully, you're looking at this and you're realizing, well, it's a difference of 100 and it's spread out over 5 lines. So 100 divided by 5 is 20. So for this map, the contour interval would be 20 units. So by units, we mean either miles or kilometers or meters. Let's take a look at this top left map over here. So we're going from 10, and then we're skipping a line. It's not labeled. Then we're going to 20. So that one's pretty easy. We're counting by 5s. Okay. The bottom left map over here, okay, I see that this contour line is labeled as 50, and this contour line up here is labeled as 100. So again, it goes from 50 to 100, which is a difference of 50. and it's going 5 lines between them. So 50 divided by 5 is 10. And then on the last map, this one's pretty easy to figure out. We're counting by 25s. So our contour interval would be 25, whatever unit is being used. Let's take a look at another.
But this might be really obvious, but please have your 5, 10, 25, 15, those tables memorized, because it's really, you're I know it might seem like only a minute or two, but it's kind of like a waste of time if you're trying to figure out, hey, what's 25 times 10? Or, sorry, 25 times 9 or something like that, right? And in those minutes, a lot of the beginning few questions only take 10, 15 seconds max. So you could easily do 2 of those questions while you're trying to figure out 25 times 9. So yeah, just make sure you kind of have those tables memorized. Yeah.
Another map. Can you figure out on this map what the contour interval would be? And feel free to pause the video. Well, hopefully you realized that we're going from 500 to 600. So we're going a difference of 100. And again, we're spreading it out over 5 lines. So we're counting with an interval of 20 meters. Once you know the interval, you can now figure out the elevation of any of the lines that are not labeled. So for example, line A, right over here, if we're counting by 20s, this line would be 540 meters. I want you to see if you could figure out what the elevation of line B would be. So think about that for a second. And hopefully you're realizing that it's 580 meters. Okay, so again, contour interval, first thing you want to figure out. The next thing that you'll notice on most maps is somewhere there will be a compass rose. And that's important because that will show you where north is. Normally, when we look at a map, north is usually up, but that is not always the case. You can see on this map that they're telling you that north is facing the right side of the map. So north is really here, and then south would be over here. So you want to look at the compass rose, you want to figure out where north is, where south is. So let's go through some of the rules of how to read a topographic map. Okay? Going back to this first map that we looked at earlier, I want you to notice when there's a cliff, what the contour lines look like. So right over here, where the land is steep, you probably notice that the contour lines are very close together. Okay? And that's always going to be the case. Rule number 1 is the closer the lines are, the steeper the slope. Or the opposite, the more spread out the lines are, the gentler the slope. We can see on the side of this hill over here, we have a nice flat area right over here. The land is pretty flat over here. And on our contour map, we can see the lines are spread apart much further than they were over there. Now, on the back of your note sheet, you have this map. I want you to go ahead and I want you to figure out where the steepest slope would be on this landscape. Okay? So we're looking for where the lines are the closest. And pretty easy to see, the lines are the closest somewhere near the top over here. Okay, you can see how close together they are. Go ahead and label that on your map on the back of your note sheet. That is the steepest slope. Okay, rule number 2 deals with streams and rivers. When a contour line crosses a river or a stream, the contour line bends and forms a V. We can see that, again, this is the map on the back of your sheet. We have this Mill River over here. And we can see that when the contour lines cross the river, they are bending and they are forming V's. You always want to look for the V's because the V's will tell you where the water is coming from. So the tip of the V shows you the source of the water. So in this case, the water is coming from over here. This would be the source. And so the water is traveling from this bottom edge of the map. Okay? The river is flowing this way, okay, towards the ocean. And it eventually goes into the ocean, and that would be called the mouth of the stream or the mouth of the river. Let's practice that skill a little bit. That's an important skill. Let's take a look at this map. I want you to see if you can figure out which way Long Creek would be flowing. All right, so hopefully you notice the contour lines are bending. They're forming V's. And again, the tip of the V shows us the source of the water. So Long Creek is basically flowing towards the south, slightly west, so southwest or south. Here's another one. Let's look at Trout Stream over here. See if you can figure out which way Trout Stream would be flowing. All right, again, we look at our contour lines. They are bending, they're forming V's. The tip of the V shows us the source of the stream. So the water is coming from here, and it is flowing down this hill into the river. We can see the same thing when we look at the river. If we look at Cedar River, we have this one contour line here that forms a V. So we know the river is flowing this direction towards the lake. Okay, so that's how we figure out which way streams and rivers are going. Rule number 3. You'll notice this landform over here has 2 hills. When they're put on a topographic map, they look like concentric circles that get smaller and smaller inside of each other. Rule number 3 is that when there are rings of circles that get smaller and smaller, that it represents a hill or a mountain. So let's look at the map, again, that's on the back of your sheet. Let's figure out how many hills there are. Okay. So I see one over here. So let's go ahead, let's label that somewhere. If I click, there we go. So there's a hill. Can you find any others? Well, you should. There are 2 others. We have one hill over here where there are circles inside of circles. We have another one over here. This area down here on the bottom right-hand corner is not a hill because it has these little marks on it, which we'll get to in a couple of minutes. Okay, so again, anytime you see circles within circles, it is a hill or a mountain. Okay? Now, what we have to do is we have to be able to figure out how high the top of the hill or the mountain is. So to do that, what we would do is we would look at our map and we'd figure out what our contour interval was. Now, we looked at this one before. So we know that this one's counting by 20s. This top contour line is 400, which means the top of the hill has to be higher than 400, but it's not going to be as high as what the next line would be. So the next line, if there was one, would be 420. So the top of this hill is somewhere between 401 and 419 meters, or whatever unit it is. So again, it can't be 400 and it can't be 420. It's got to be in between. How about on this map? Well, again, we're counting by 20s. So if this top line is 600, it means the top of the hill has to be somewhere above that, but lower than what the next line would be. So it's got to be somewhere between 601 and 619. Okay, so rule number 4 says the highest possible elevation of a hill is just below the value of whatever the next contour line would be, if there was a next contour line. Okay, so let's figure out what the height of these hills. Okay, so let's start with this one over here. So this contour line is 300. So let's figure out what we're counting by. So here's 200, here's 300. So we're counting by 20s. So if we come up the hill, so this is 300, 320, 340, 360, 380. So this small loop is 380, which means the top of the hill has to be somewhere between 381 and 399. It can't be 400, because if it was 400, we'd have another line there. So the highest it could possibly be is 399 meters. If we take a look at this hill, we could figure out the same thing. We could figure out the same thing down here. Okay. So in this case, here's 200. So the circle where letter Z is, that's 220. The next line would be 240. So the elevation can't be that high. It's got to be underneath that. So the highest would be 239. All right, moving on. Rule number 5. Sometimes we don't have a hill. Sometimes the land dips down and forms a depression. So this is the top of a volcano, and there's a crater up here. That's a depression. On a contour map, we show depressions by using these little marks that are called hatchers or hatch marks. So again, we'd find these where there's a volcanic crater, or maybe a meteor hit the earth and left a crater. So on your map, we see that right over here, we have a depression. So these little hatcher marks tell us that the land is going downwards. Okay? Now, the last rule, the 6th rule, tells us how we would figure out how deep the bottom of the depression is. Okay? So the first part of the rule says that when you're at a depression, the first hatchered line, so the outer circle, has the same elevation as the previous contour line. So in other words, this line over here has an elevation of 120 meters. So our first line with the hatcher marks is also 120 meters. Then what we do is we start to go downwards. So if this is 120, it means the next line is going down by 20. So it's going to be 100. To figure out the deepest that this depression could be, what we do is we say, all right, if there was another line, what would that be? So if there was another line, it would be 80, but that line's not there. So this depression can't go down to 80. So it's got to be a little bit higher than 80. So the lowest possible elevation is just above whatever the next contour line would be. All right, so here's another contour map. Hopefully you can use some of the rules we went over, and you could figure out some of the topography, some of the shape of the landscape.
Okay. Yeah, I think that video shares a lot of like really important stuff. Let me see. Do I have anything left? Okay, homework. So yeah, just a reminder, if you haven't finished the homework, please send it to me. Homework for next week, I haven't decided yet, so I'll post it in a bit, probably today. Wait, who was it that couldn't send me their homework?
It was me.
Okay. I will. Hold on. Okay, I'll try to send you an email and then see if you can just like reply to that email
Okay.
with your homework. Yeah. But I think that's pretty much it for today. I'll send the recording, I'll send the PowerPoint on Teams, as well as like any of the other resources I said I would send. And then I'll see you guys next week. If you guys have any questions, you can like tell me right now, or you can like mention me and let me know. But other than that, I think that's it for today. And I'll see you guys, next week. I'll let you guys know what time it is. Yeah. You guys can leave now.
Bye.
Yeah, bye.